Hello. In this video, we're going to do an example for the report the results stage. But before we can do that, we need to revisit an example we did in a previous section, and that was about the disc golf putting challenge. And in that section, we focused on having a model for the probability versus distance. And now we're going to focus more on the scoring scheme part of that problem, because that's what we actually want to report the results about. So, as you recall, the question was find the scoring scheme for a putting challenge, where the score should reflect the difficulty of the putt. And so, as you recall, we already know, or at least we have a model for P of D. And that's, of course, the probability as a function of distance. And so then the question is, well, how do we find a scoring scheme? So in other words, we want to find S of P. And if we can find S of P, so in other words, a score based on probability, then we can plug P of D in for P, and then we'll have a score based on distance, which is what we'll actually want to implement. So, as you recall, we know the probability ranges from anywhere between 0 and 100%. And of course, if it's 100% chance of making the shot, that should be worth less points than if it was almost impossible to make. So you might pause the video for a moment and think about what type of function would have that sort of feature, and then I'll give you my choice after we resume. All right, so let me give you one example, and I'm going to assume that the maximum score, and of course this could be adjusted, but the max score possible is 100 for one throw, for one putt. All right, so one possibility then is to let, and we'll just call this S1 of P, is just 100 over the probability. And this certainly has the feature that because it's the reciprocal function, since we're saying it's inversely proportional, that at probability near 0, we're going to have infinite points, which is a problem. And then as we get further along the x-axis here, we're going to be closer and closer to 0 points. In fact, you can see that if the probability was 100%, then we would only get 1 point for that throw. So that doesn't seem so bad, but there is a little bit of a problem of having an infinite number of points for something that's impossible, or a whole lot of points for something that's close to impossible. And so that's why the maximum score of 100 is a way to bound that. So one adjustment to that is to just add 1 to the denominator. And so notice that's still going to be basically the same function, except now we're shifting it. So now if we have something that has a 0 probability of success, well, now we're dividing by 1 instead of 0. And so now we get a picture that looks something like this. Now, at first glance, this one maybe seems like an improvement, and maybe that seems good enough. But it's always good to actually see your model in action, right? So we're still analyzing the model for the moment. And so let's take a look at, let's compare these two models. So we're going to go from distance, and then this is using our probability function from the previous section. And then here's our first scoring model, where as you can see it goes from 1 point all the way up to infinity as we work our way up this graph. And then the second scoring model, notice we cap out at 100, but there's still a problem with this model in the sense that for most distances, you're only getting a few points, and then you get a whole lot of points if you're really far away. So that doesn't seem spread out enough. It seems like all the points are based on just the last few feet. And again, there's no reward for putting more than 27 feet, but that's a separate issue. So let's try one more model. And again, I encourage you to think about how you might tweak this function to get a better fit. But here's one more solution. So let's say 2,000 divided by the probability plus 20. All right, and again, we're still assuming that the probability is between 0 and 100. Okay, because we're expressing it as a percentage. And so now here's our third model, and notice now the scoring is more spread out. Now, maybe that's too spread out. Maybe we don't like these numbers better than the others. Maybe we could do better. Again, we're not trying to get the perfect model here. We're just getting something that's reasonable enough that we can talk about implementation. So remember, in the report the results stage, you would want to justify your model to whoever your audience is. So whatever organization came to you with this question, you want to tell them about the restriction that it's only valid up to 27 feet. And you might want to say something about this was just based on a certain skill level of one person. All right, some of those weaknesses or limitations of the model. And then you would also point out your scoring model. Now, keep in mind, our scoring model is actually S3 of P of D, so it's a composition of functions where P of D is equal to a piecewise function. As you recall, it was 100 when D was between 0 and 7, and it was 100 minus 5, D minus 7, when D was greater than 7 and D was less than 27. All right, and S3 of P, just to remind ourselves, is 2,000 over P plus 20. So the problem is this is a messy formula, and here we have some example numbers just to help us understand the model, but the actual model is the composition of these two functions, which most likely is not going to be acceptable for the organization that's asking. So this is where we come to the implementation phase. And so we would like to make this model usable and useful enough that the organization can just use it and not have to worry about some calculations that they might not want to mess with. So one option is we can make a chart. So here's a little bit of an example of a chart, but maybe we make a distance. Maybe we make a spreadsheet that goes from 1 to 27 and then has the score for each of those distances. And we could print that off on a piece of paper or a card, maybe a laminated card, and hand that out. So that would be okay. That would be in the example of a chart that we talked about before. We also talked about an online calculator, or in this could even a simpler form of an online calculator is a spreadsheet, by the way. So we could just have a few cells in a spreadsheet where someone could type in their distance and the spreadsheet would calculate the score. Or you could make an app for a phone or tablet that would spit out the score for any particular distance. That's probably not real practical for this because people probably don't want to mess with that level of technology when they're just putting probably outside. So the third option might be a physical tool. So what sort of physical tool would be helpful here? Well, for a problem like this, maybe a string would be the way to go. And the string could have markings on it that as you went further along, we could calculate the score for various distances, and then that score could be marked on the string accordingly. And so if someone wanted to see how many points they were going to get for a particular distance, they could just unwind the string, tie one into the basket, unwind it, and then throw from a particular spot, and they would know what the points were going to be. So that's an example of a physical tool. And then the fourth option is a rule of thumb. So remember, a rule of thumb is where we're sacrificing accuracy to gain in simplicity. And this may be a situation where that actually makes sense because this isn't a real important or precise sort of situation anyway. It's just something for fun. So we wanted to keep it as simple as possible. And so maybe it's a little bit like on a basketball court when some shots are worth 2 points and then there's a 3-point line and anything outside of that is worth 3 points. Now, presumably our organization wants something a little more interesting than that. And so here's one possible scheme. So this is still based on our model, but it's simplified it down to just zones. And so then one could have just certain regions marked out on a course or by a basket and show that if you're within 0 to 7 feet, all those shots are going to be worth 15 points. If you're 8 to 14 feet, all those shots are going to be worth 20 points. And then if you're 29 or more, you get 100 points and so on. So notice this isn't as elegant of a solution as using the formula for every possible distance, but it is going to be a little easier to use and maybe easier to understand for the spectators and participants as well. So that's just one example of rule of thumb, but again, it would be a conversation between you and the client to decide which one of these was the best. But what you probably would not want to do is just leave it at a formula and let them try to figure it out. So that concludes the modeling process, the various stages. In Chapter 2, we will look at various mathematical tools to help us build the model. We'll see you there.